This is the CharlieClock. It is a PCB with 132 LEDs, 12 for the hours in blue, 60 for the minutes in green, and 60 for the seconds in red. This is an extension of Project 2.6, except the real time is represented on a PCB via LEDs. Here's how this project works. This project functions on the fundamental process of CharliePlexing, which is a technique to control more LEDs than the number of available inputs. In this case, 6 LEDs are controlled with only 3 inputs. Without CharliePlexing, this project would require 132 inputs for 132 LEDs, which would make it way more complicated than necessary. In CharliePlexing, we have 3 pin states: high, low, and input, which is a high impedance state. Its purpose will be clear as we examine this circuit. Suppose we wanted to make this LED L2 high. First, we would make pin 2 high and pin 1 ground. So current would flow in this direction, go here, and then go to ground. However, if pin 3 was also ground, then we would notice that the L3 LED would turn on as well. So to avoid this issue, we add our input state, which will set this pin 3 as a high impedance state, preventing other LEDs from turning on. And now I'll introduce a formula which can be calculated to figure out the number of LEDs that can be turned on using CharliePlexing. And this is the permutations formula. So we'll have 2 parameters, which is N and R. N is the number of inputs, and R is our state, which is either anode or cathode. And the formula for this is N factorial over N minus R factorial. So in this case, we have N, which equals the number of pins, which is 3. So we have 3 factorial. And then we have R, which is 2. And then we'll put this into our equation. As we simplify this, we'll get 6 as our numerator, and we'll have 1 as our denominator. This leads to 6, and we can see here that this equation is correct, as there are 6 LEDs in this circuit. There's also another equation we can use to figure out the number of LEDs that can be turned on using CharliePlexing, and it is N squared minus N. And we can see that this equation works as well, as we input 3 for N, then we get 6. So N is just basically your number of inputs. And then we can also verify this using my calculator to calculate why 132 LEDs need to be used for the project. I go 12, PRB, and PR, 2, we'll get 132. Here's the code for the project. First, all pins are defined. Then all elements in the array follow the structure of anode and cathode. So since there are 12 hours, we have 12 elements in the hours array, 60 in the minutes array, and 60 in the seconds array. Next, the number of elements in each array is counted using num hours, num minutes, and num seconds. And then each pin from 1 to 12 is set as an input, and the hours and seconds pin, which allow the user to change the time, are also set as an input. Next, there are 3 functions called display seconds, display minutes, and display hours, which show the current seconds, minutes, and hours. They all follow a similar structure. First, the current second is gathered from the array, and then the anode is set to output, the cathode's output, then the anode is set to high, and the cathode set to low. There's a small delay of 5 milliseconds for POV, then the anode is set back to low, and then both are set back to input for a high impedance state. Finally, in the loop function, we define our variables again, and then this code right here increments the code every 30 milliseconds and checks if any of the arrays defined earlier are overflowing. If they are overflowing, they reset back to 0. And then there are inputs for the hours, minutes, and seconds, which are wired to buttons, and if any of them connect a digital high, then the time is incremented by 1. And then finally, the minutes and hours are displayed. This CharlieClock is a fantastic introduction to CharliePlexing. Here it is working in full action.